Hi, Efren here with Stress Engineering. For this week's Failure Friday, we've been asked to test out different materials to see how they behave in a cryogenic situation. So we're going to fire up the old thermotron to negative 100 degrees to see how these items behave. We've also been given some 3D printed steel components to see if digital inventory is a solution for the oil field.
So these tubes were 3D printed using a process called laser powder bed fusion. The way laser powder bed fusion works is it lays down a layer of metallic powder and a laser shoots down and melts the cross section of the part that's being built, and then a new layer is spread over and the part is built up layer by layer until you complete the entire build. This part was printed by our friends over at Kunst Godwin, who did a really good job printing this out of Inconel 713. We also have a part that was printed somewhere else out of a 316L stainless steel material that was also printed in the same direction. However, it does not perform as well. So we saw something interesting with the burst testing of the 3D printed tubes. So one tube couldn't even contain much pressure. It actually leaked through the wall. Another tube, made by a different manufacturer, was able to withhold pressures up to 42,000 psi. And the reason for this actually has to do with the storage temperature of the powder that was used for the 3D printing. So the tube that couldn't hold any pressure, the powder was actually held in a very humid environment. And so that humidity got into the powder and made for the manufacturer of the 3D printing of a bad part. That's why there's a lot of complex variables that can affect the quality of 3D printed parts that you can really find out through full-scale testing. So with the copper tube, at ambient temperature, it burst around 6,100 psi. But at the colder temperature, it burst around 9,800 psi, much higher, and this isn't necessarily unexpected. So for steels, because of their crystal structure of a body-centered cubic, BCC, they can exhibit something called a ductile to brittle transition temperature. Copper, however, has a different crystal structure of FCC, face-centered cubic, and so it doesn't exhibit those properties, and in fact can have a higher strength at lower temperatures.